19 is on review of inverses and exponential and logarithmic equations. So you guys are probably going to remember a lot of this, exponential and log equations, but you probably, you haven't seen some of this other stuff. Yes? Yeah. Abby, could you hit one of the lights, please? All right, so it says a function f is called one-to-one if it passes the horizontal line test. So if it never takes on the same value twice. So if f of x1 is never equal to f of x2. So you don't have two y values that are the same, basically. So when a function is one-to-one, it has a unique inverse and passes the horizontal line test. The inverse is defined by f of x equals y if and only if f inverse of y equals x. Okay, so we've done inverses before in like algebra 2. We did a little bit in pre-calc. So let's first talk about what makes something one-to-one. So when I have f of x equals x squared, can you guys visualize that in your head? It's a parabola, right? Is that one-to-one? Does it pass the horizontal line test? It does not, right? Because there are two places where we have, like, let's say we have 2, 4, and we have negative 2, 4. Okay, so we take the same value twice. We take the y value twice. Okay, so it is not one-to-one. Okay, but if we have f of x equals x cubed, is that going to be one-to-one? Yes. Okay, so it does pass the horizontal line test, right? So passes the horizontal line test, so this is one-to-one. Math people are very lazy. We don't like to write out one-to-one all the time, so you might see one-to-one like that. All right. Okay, so what it means is that there is no unique inverse if it's not one-to-one. So if you had f of x equals x squared and you tried to find the inverse of it, do you guys remember doing that? Like you'd have y equals x squared. You don't have to write this. You'd switch your x and y, and you'd solve for the new y value. But when you solve for the new y value, you have to take the square root of x, and then whenever we take a square root, we do plus or minus. So what that is it's actually two functions. It's the positive square root of x, and it's also the negative square root of x. Okay, so it's not a unique function when you do the inverse. There's two functions listed. Everybody understands? All right, so let's find the inverse of the function f of x equals x cubed plus 2. So this is one-to-one. There is going to be a unique inverse. So we first switch our x and y values. So we have x equals y cubed plus 2. And we solve for the new y. So we're going to subtract the 2 over, and we get rid of the cubed by taking the cube root. So we have y equals the cube root of x minus 2. So that's the inverse. All right, so clearly we're going to do something with derivatives, right, with calculus. So it says find the inverse function of g of x equals 4x minus 1 over 2x plus 3. Yes. So when we have a quotient like that, it's a little bit harder to find the inverse. Do you guys remember doing this one in Algebra 2? We did one like this a long time ago, 2 years ago. All right, so we're going to switch our x and y first. So go ahead and do that. So switch your x's and y's. So instead of having y for g of x, I'm going to write x equals 4y minus 1 over 2y plus 3. And we multiply our denominator over. So we're going to get x times 2y plus 3 equals 4y minus 1. So we have 2xy plus 3x equals 4y minus 1. And we want to solve for y. But it's a little bit tricky. Do you guys remember how to solve for y in a case like this? Yeah, get all the y's on one side, pull out the y, just like we did the other day with implicit differentiation with dy over dx. Same idea. So I'm going to subtract my 4y over, so I get 2xy minus 4y. And I'm going to subtract the 3x to the other side. I now pull the y out to the front so that I can solve for y by dividing that whole chunk over. So I'm going to have y equals negative 1 minus 3x over 2x minus 4. Okay, so that's going to be your inverse. So instead of y, I'm going to write it as g inverse of x. So g to the negative 1 of x. All right, and your test probably won't leave an answer like that. If you have a lot of negatives, see how I have a lot of negatives on top and the negatives on the bottom? They might multiply by negative 1 on the top and bottom, so you might have 1 plus 3x all over 4 minus 2x. That's probably how your book, like how, not the book, but the AP test would leave your answer. Okay? All right, so let's talk about finding the derivatives of inverses. So for 4a, it says find the derivative of the function f of x equals x cubed minus 4. So we just did one similar to that. Well, we found the inverse already. But let's go ahead and find the derivative. So if I find the derivative, f prime of x is going to be 3x squared, just that. All right, and then it says, in f of x, we have the point 2, 4. So if you plug in 2 to the original, do you guys see it? You get 2 cubed is 8, minus 4 is 4. So you do get the point 2, 4. It says, what is the slope at that point? So we knew that f prime of x was equal to 3x squared. So the slope at an x value of 2, we just plug in 2. So we get 3 times 2 squared, which is 12. So the slope would be 12 at that point. Okay, it says in the inverse function, f inverse of x, we know that we switch all of our x and y values. So if we had the point 2, 4 before, what will we have on the inverse? 4, 2, right? We switch our x and y. So we're going to have the point 4, 2. So it says find the inverse of f of x and verify that we do have this point, and then find the slope of f inverse at this point. Okay, so we're going to find the inverse. So we started out with f of x equals, what was it? X cubed minus 4. So we're going to switch our x and y to find the inverse. We add the 4 over, we take the cube root. That gives us y, so that's going to be our f inverse of x. Does everybody see how I did that? So it says, well, find the slope of f inverse of x. Okay, so f inverse of x, if I take the derivative, so I'm going to write prime on the outside. F inverse of x prime is going to be the derivative of the cube root of x plus 4. Well, how do I take the derivative of the cube root of x plus 4? I think of it as x plus 4 raised to what power? The 1/3, right? And then I use what rule? The chain rule, right? So I'm going to do 1/3 x plus 4. I have 1/3 minus 1 as my power. So 1/3 minus 1 is negative 2/3 times the chain. Well, the chain luckily is just 1 in this case. So if we're finding the slope at 4, 2, the way we would write the notation is it would be f inverse of 4 prime equals, and then you'd plug in 4. So we have 8 to the negative 2/3, 8 to the negative 2/3. Right? What is 8 to the negative 2/3? It's going to be 1 over 8 under a cube root squared. What do we get there? 1/4. So I have 1/3 times that answer, 1/4. So my answer is 1/12. All right, so D says we'll find the slope of f of x at the point negative 3, negative 15 and compare it to the slope of f inverse of x at negative 15, negative 3. So let's do this one more time. So we don't have to do all the derivatives. We've already done that. So the slope at negative 3, f prime of negative 3, was going to be 3 times negative 3 squared. We go back up to the f prime of x equation. So what do we get there? 27. And then if I find the slope of f inverse, so f inverse prime at its x value, which is negative 15, then I go back to my f inverse equation right there. Did I do that right? All right, so my f inverse equation, 1 over 3. I feel like I have something wrong here. Negative 2/3. Negative, what did I do? Maybe I do. So we must have the point at slope at 4, negative, or 4, 2. I plugged in 4. I don't know what I did. Plugged in 2. Is 3, negative 15 a point on the original? Maybe I changed my problem. If I plug in negative 3, do I get negative 15? Negative 27 minus, no, I don't have negative 3, 15, do I? I have negative 3, what's my original point? negative 31. Is that right? So that's where my error was. This should be negative 3 comma negative 31. I think I changed this problem from previous years. So this is going to be negative 31 comma negative 3. So I'm going to plug in negative 31. Sorry about that. There has to be a pattern, right? Because I knew that I was wrong. So we got to figure out what this pattern is. So I have 1/3 negative 31 plus 4 to the negative 2/3. So negative 31 plus 4 is negative 27. So I'm going to have 1/3. And then I have negative 27 to the negative 2/3. So I'm going to have 1 over negative 27 in a cube root and then squared. So I get 1/3. 1 over negative 3 squared is 9. So my answer is 1 over 27. So do you see a pattern? So look at B and C. So we had 12 and we had 1/12. On part D, we had 27 and we had 1 over 27. Yeah, they're the reciprocals of each other. Okay, so that's the pattern. The inverse's derivative is the reciprocal of the original one. And the reason that is because of this little picture here. Okay, so let's write. They are reciprocals. Okay, and it makes total sense if you think about what an inverse is. So previously, like in Algebra 2, we knew that the inverse was a reflection of the line y equals x. So if we had something like that, right, we could find the slopes of those. If I find the slope between 2 points, on the original f of x, it's your y values, y2 minus y1 over x2 minus x1. But then on the inverse, what happens to our x values and y values? They switch, right? So if I find the slope, it's no longer like y's minus x's, or y's over x's. It's now the original x values over the y's. Do you guys understand what I'm saying? Everything flips around. Okay, so that's what this little picture is. It says, you know, if we have the slope at a certain point, it ends up being the reciprocal of the other one. So their signs are the same. They're both positive. It's not opposite reciprocals like perpendicular, but they're reciprocals. So if this one was like 2/3, this one would be like 3 over 2, right? Actually, I probably did those backwards because one looks steeper than the other. I should have done 3 over 2 and 2/3. Do you guys understand that concept? Because all of our x's and y's switch, so when we find the slope at a point, we do y2 minus y1 over x2 minus x1, but on the inverse, it will now be the x values, the original x values over the y values. Okay, so it says sometimes it's not easy to find a function's inverse. So therefore, it's quicker to use the formula above for the derivative of an inverse. So let's look at the formula. So this formula is right here. I wouldn't say that it's crucial on the AP test. It has popped up on the AP test. There's maybe 1 or 2 questions on this each year. I don't think it's something that you have to memorize. But if you want to get a 5, maybe memorize it, right? But it's really not that bad. Basically, the way I tell people to memorize it is if you do inverse prime, then on the denominator, you're going to do prime inverse, okay? So we're going to switch things around. So inverse prime, prime inverse. All right, so it says use the formula to find f inverse prime of A. So we're finding f inverse prime at our A value of 4. So it's going to be 1 over f prime of f inverse of 4. Okay, do you guys see that this is not easy to find the inverse of? If I was trying to find the inverse, you don't have to write this out, but I would have x equals 2y cubed plus 3y squared plus 7y plus 4. How do you find the inverse of that? Right, pretty difficult. We don't want to find the inverse of that, so we don't. We ignore that. All right, so we start from the inside, and we're like, well, what's f inverse of 4? Okay, so if I have f inverse of 4, it means what do I plug in to f of x to get 4 out? So it's solving the equation f of something is equal to 4. It's always, on the AP test, always something that is super easy. Can you guys all do that in your head? What can you plug in for x to get 4 as an output? 0. Do you guys all see it? It's 0. because we plug in zeros all here and we get 4 left. So that means that we're finding 1 over f prime of 0. Can we find f prime of x? Sure. F prime of x is going to be the derivative of our f of x formula. So I have 6x squared plus 6x plus 7. So what is f prime of 0 then? 7. So our answer is 1/7. So you can spend a lot of time trying to find the inverse, or you can just use that formula. All right, so let's try another one. So we want to find f inverse prime of a. So the derivative of the inverse. Okay, f inverse prime of 2. All right, so we do that by doing 1 over. Do you guys remember what I said? Switch the prime and the inverse. So we're going to do f prime of whatever f inverse of 2 was. It's like the coordinate pair that goes with 2. 2 comma something and something comma 2. So if we're finding f inverse of 2 equals something, that just means that f of something is equal to 2. This one's a little bit harder to do. Anybody have it? Can you do it in your head? What do you think? It is 1.5. Good. Jake does a lot of steps in his head. I'm always like, show your work, Jake. All right, so I have f of x equals, I want it to equal 1 over x minus 1. So I want 2 to equal 1 over x minus 1. So you can solve that out if you didn't know how to get it in your head. Then multiply it out and add over. So we do get x equals 3 over 2. So this means I have 1 over f prime of 3 over 2. So 2 goes with 3 over 2. So 3 over 2 comma 2 for f and 2 comma 3 over 2 for f inverse. All right, now we just have to find f prime. So off to the side, f prime of x. Well, we know f of x was 1 over x minus 1. So we can do this derivative a couple different ways. You could do the quotient rule pretty quickly, or you could do the chain rule. If I was going to do the chain rule, how would I have to rewrite it? X minus 1 to the negative 1, right? So you could do the chain rule if you want to, or just do quotient rule. So I do low, d high is 0, minus high, d low is 1, all over the square of what's below. So you get negative 1 over x minus 1 squared. So if we plug in 3 over 2, we get negative 1 over 3 over 2 minus 1 squared. 3 over 2 minus 1 is what? 1/2. Square it. 1/4. If you have negative 1 divided by 1/4, what do we get? Negative 4. So this is 1 over negative 4, or negative 1/4. That's our answer. Do you guys kind of understand it? I know it's weird. I didn't like this at all. I never learned this when I was in school, actually. My teacher just skipped it. But I didn't like it when I was first teaching it, and I was like, wait, what? But really, it has to do with the slopes. The slopes are reciprocals of one another. All right, can we move on from that? Oh, well, let's do one more. So it says, let f of x equal 1/4 x cubed plus x minus 1. So it says, what is the value of f inverse of x when x equals 3? So we want to find f inverse of 3 equals something. So what does that mean? It means f of something equals 3. Okay, that's a lot harder. Okay. So what we're saying is 1/4 x cubed plus x minus 1 is equal to 3. And you could subtract the 3 over and try to solve it algebraically. It's pretty hard. Okay, you could do the p over q. Do you guys remember rational roots theorem? Or you could use a graph and figure out where it's crossing the axis. So it's crossing somewhere. But we need to find what it is. But what I told you is on the AP test, it's always something that's very, very easy. So you could try 1, but what happens if you're trying 1? Well, then we have that 1/4 that's still there, right? 1/4 plus 1 minus 4, that's not going to equal 0 because of the 1/4. So let's try 2. 2 cubed is 8. What's a fourth of that? 2 plus 2 is 4 minus 4 is 0. It works out, right? So it's usually something very, very easy to find. So it's f inverse of 3 is equal to 2. So then it says, what is the value of f inverse prime of 3? So f inverse prime of 3 by the formula is 1 over f prime of f inverse of 3. So it's 1 over f prime of 2. We just found that. So then off to the side, we need to find f prime of x. So it's going to be 3/4 x squared plus 1. So I'm going to plug in 2. So I have 1 over 3/4 2 squared plus 1. I guess I could have just plugged it in over there, right? So what do we get? 4 on the bottom. Yep, so I get 1 over 4. Do we feel somewhat comfortable with it? Yeah, it's just weird. It's like a weird formula to remember. All right, now we're going to do the easy stuff. So it says in your previous math classes, you learned that exponential functions have inverses. So we say that a to the y equals x if and only if log base a of x equals y. Are you guys feeling comfortable with logarithms and exponents? Yeah. All right. So a couple of the different properties that we're going to use the product property, which says log of a times b equals log of a plus log of b. The quotient property, division, is related to subtraction. Power property, do you guys remember that the power can go to the front? It has to do with this property. That's why it works the way it does. Because if you had log of a times a times a, it'd be log of a cubed, right? But we know that log of a times a times a can be written as the sum. Log of a plus log of a plus log of a is 3 of the log of a's. Okay, so that's where that comes from. Hopefully these are somewhat familiar to you. The inverse property just basically says if you have log base a and a are next to each other, then it becomes m, because the m goes to the front, and log base a of a is 1. Or a to the log base a of m equals m. Do you guys remember that? So if I have like 8 to the log base 8 of 7, we get 7. Some of you guys have panic in your eyes. I'm a little scared. Are we good? All right. And then the change of base formula just says you can change a logarithm to any base. Usually we change to base 10 or natural log, so we can use our calculator. And then limits, so you can use a picture of a logarithm. Logarithms look like this. They go through the point 0, or not 0, 1, 1, 0, just like exponential functions go through 0, 1. They have a vertical asymptote. They do not have a horizontal asymptote. So you guys can play around with your calculator if you want to. If you put in log of, like, I'm just going to do 1 with a whole bunch of zeros. So I have log of 1 with lots and lots of zeros. It equals 24. I must have had 24 zeros, right? So it goes very, very slowly, but there's no, like, limit to how big it can get. All right, so the limit as you go to infinity is infinity. It just goes very slowly. And the limit as you go to 0 from the right is going to be negative infinity. All right. Are all these familiar? Can you guys do these quickly? So try to do it along with me, see if you get the right answers. Log base 3 of 3 is 1, right? Because what we're saying is 3 raised to the 1 equals 3 when we switch forms, right? So log base 3 of 3 is 1. 3 raised to the log base 3 of 8, 8. Log base 9 of 81, 2, because we're saying 9 to the 2 equals 81. Ooh, tricky. How about this one? Any guesses? It is 1/4. Good. Okay, if you didn't know that, the way that I taught it in Algebra 2 is you could always write this as equals x. And you could say, okay, 9 to the x equals square root of 3. And then you can get them so they have the same base. So you could say, okay, 3 to the 1/2 equals 9 is 3 squared, so 3 squared to the x. So I get 3 to the 2x equals 3 to the 1/2, so 2x equals 1/2. And then you get x equals 1/4. So you can do that if you need to. But you guys should be getting to the point where you can do a lot of these in your head. set my powers equal to each other. All right, so if I have two logarithms with the same base and I have subtraction between them, how do I combine them? With division, right? So it's going to be log base 4 of 192 over 3. Do you guys know what that is? 64. So log base 4 of 64 is 3. Good. But you could have combinations of subtraction and addition. So it's going to be log base 2 of 6 divided by 15. But then we're going to multiply that result by 20, right? And we're taking the log base 2 of all of it. So you can reduce things out. 6 times 20 is 120 divided by 15. Yeah?
You have 2x equals 1/2. How do you get x equals 1/2?
Oh, I erased it to write 1/4 again, and I must have written it wrong. 1/4. My 1/4 was sloppy, and then I got distracted. Thank you. All right, so the next one. So if I have 6 divided by 15 times 20, what's that going to be? What was it? It was an 8?
Log base 2 of 8.
So log base 2 of 8. So your answer is 3. Good. And this one, if I have 1/2 log of 16, there's really not much you can do with this. The 16 can go up as a power, log of 16 to the 1/2, which you can rewrite as log of 4. So you might see things written in different ways. And that's the frustrating thing about the AP test, because it's multiple choice, a lot of it. So when they have logarithm answers, they always put them in a funny form. I don't know why. They just mess with you. It's just mean. So if I have log base 11 of 121, that is 2. And then this one, log base 2 of 30. I don't know what that is. If I was going to find it on my calculator, what I would do is log of 30 over log of 2. I would change the base, so it's base 10. So log of 30 divided by log of 2 would be 4.907. Right, 3 decimals. Some of you guys have the log base key on your calculator, though, so you don't even have to worry about the change of base. All right, one thing that we're going to be doing in the next section is we're going to be doing something called logarithmic differentiation. So this is where we expand things out. So it basically is going to make taking a derivative much, much easier. So if I have log base 8 of 5y squared, I can expand it and write it as separate logarithms. Okay, so what I would do is I would write log base 8 of 5 plus log base 8 of y squared. Do you guys see how I got that? And then we're going to take any powers that we have to the front. So our expanded form would be log base 8 of 5 plus 2 log base 8 of y. And we would leave it like that. And that's going to be super, super helpful when we find derivatives, to expand things out. So go ahead and try the next one. So we're going to try to expand it out. So we're going to have log, the numerator is going to break into log of x squared plus log of the cube root of x minus 1. Then we're going to have minus log of 2x minus 1 in parentheses. Do you guys all have that? And then the last step, we bring powers to the front. So if I have this cube root, what power is that? 1/3. So I'm going to have 2 log of x plus 1/3 log of x minus 1 minus log of 2x minus 1. That's it. So the same thing happens when we expand. We're going to combine these. We're going to go in the opposite direction. Okay, so this one, if I combine it, I'm going to bring my powers up. So I'm going to have natural log of 6 plus natural log of x cubed plus natural log of x squared minus 2 quantity squared. So when I combine it into one logarithm, it's going to be natural log 6x cubed times x squared minus 2 squared, like that. You cannot bring the squared in unless you actually like FOILed it out. So we would leave it like that. Still feeling pretty good about these? So the next one, I'd bring the 1/3 up, or the 1/2 up, and I'd bring the 2 up. So I'd have log base 3 of y plus log base 3 of 81 to the 1/2. What would I write? 9, plus log base 3 of x minus 2 squared. And then log base 3 of 9 is actually a number. It's 2, right? So we're just going to combine those other logarithms. We're going to combine this one, and we're going to combine this one. So we're going to have 2 plus log base 3
of y times x minus 2 squared, like that. And that's combined. All right, and then the last things we have are actually solving equations. So hopefully you guys still feel good about these. If you don't, then just come find me. So if you have totally forgotten logarithms, I'll help you. But we did do it in Algebra 2 and Pre-Calc, so it should be somewhat familiar. So if you have something like 9 and 27 as your bases, I wouldn't go the route where I take the log of both sides. Okay, I would try to get them to be the same base. So I would rewrite 9, so it's 3 squared, and I'd rewrite 27, so it's 3 cubed. So we have 3 squared raised to the 8 minus x equals 3 cubed to the x minus 3. So we're going to have 3 to the 16 minus 2x equals 3 to the 3x minus 9. And then do you guys remember what we do? Yeah, we just set the powers equal to each other. Because we have 3 to some number equals 3 to another number, those numbers have to be the same. So we say 16 minus 2x equals 3x minus 9, and we solve it out. We end up getting x equals 5. Sorry, my pen is like smearing. So x equals 5. It looks like 6, but it's a 5. 5. There we go. But if we do have one where we don't have bases that can be the same, like the next one we have 4 and we have 5, okay, then we can switch it from exponential to logarithmic form, or we can just take the log of both sides. Do you guys remember what I mean? So like there's two ways to solve this. So the first way would be to write log base 4 of 5 equals x minus 1. So just switch forms. I personally don't do that way. I don't know. I don't like to think about it. So what I do when I see an x as an exponent, I get it in this exponential form right here. And then I take the log of both sides. And I would do natural log. Okay? So I'm just going to do natural log of 4 to the x minus 1 equals natural log of 5. Because I need a logarithm in order to pull powers to the front. So if I have an x that's raised as a power, that's the only way to drop it. So I'm going to have x minus 1 times natural log of 4 equals natural log of 5. So natural log of 4 is a number, so I divide it over. And then I add the 1 over. So I'm going to have whatever natural log of 5 over natural log of 4 is plus 1. I did that for just long.
That's fine. You can do that. So I think on your homework I asked you to write the exact answer and the approximation. So this is the exact answer. And the approximation would be 2.161. So if I say exact answer, that's what it is.
Would it be okay if we had 1 plus log base 4 of 5?
Yeah, you could also have log
that
base
would be
4 of 5 plus 1. That would be the same thing.
as
Yep.
with the chain.
All right, don't pack up yet. Let's finish these last ones. So if I have log base 4 of 100 minus log base 4 of x plus 1, I have two separate logarithms, so combine them with division. So we're going to have log base 4 of 100 over x plus 1 equals 1. And then we just switch forms. So from logarithmic to exponential, do you guys all remember how to do that? 4 to the 1 equals what's left. So we do 4 to the 1 equals 100 over x plus 1. And some of you guys are super smart. You don't have to do all the cross multiplication and so on to solve this. Think about it. 100 divided by something gives me 4. What does the x plus 1 have to equal? 25. So x is going to equal 24. And then same thing here, make it easy on yourself. I wouldn't solve an equation that has x cubed. I would bring that 3 to the front. And then I would divide it over. So I have log base 5 of x equals 2. So 5 squared equals x, so x equals 25. It's much easier than finding 5 to the 6th. Can you imagine? I don't know what 5 to the 6th is. Don't do it that way. All right, so I'm going to pass out your homework for you.